All right, we're starting with page 238. This is module 2, topic 2, lesson 2, part. We're going to be working on activity 1 and 2. Starting in activity 1, it's connecting the rate of change representation. So, in the previous lesson, we talked about the company US Shirts that they sell shirts for $8. And we're going to be relating this to a ratio of a vertical distance over a horizontal distance, or just the word slope. Um, Looking at the table and the graph, they're representing the same thing. Number one, it says explain the meaning of each ordered pair in terms of the situation. Right, so as we can see here, we have 0, 15, and that's noted right here. So what does this mean, right? So for 0, this is number of shirts. For 15, this is total cost. So this means the X value is total shirts is that it costs $15 for 0 shirts, right? So that the 15 is what we call is the y-intercept. I'll put y-int. And, well, actually, we'll just leave it like that. Right, so this is an initial fee that we have to pay. This is the setup fee that we have to pay to design before ordering any shirts. Okay, next one, 0 and 23. This is, right, we'll put it costs. So it costs $23 for one shirt. And right, although we can see that on the table, right, we can also see that on the graph. If you go up to the graph here, I think that it's reasonable to say that that is about at a height of 23. Right, for the first one, 0, 15. Yep, if we go up from here up into the blue line, yeah, I would say that's about 15. All right, but let's move on to the next one, number 2. Use a right triangle to verify the slope of the line is $8 per shirt. So we can choose this point right here, right at the beginning. Right, but remember, when we choose a point, we want to pick a point that's a good point on the corner of the squares of the grid. The only one that I really see here is this one at the top. Let's go ahead and put our rise and our run. So I'm going to just draw a line going like this. And then to the right. And just be careful with our units. For our x-axis, we are going by increments of 1. For our y-axis, we are going by increments of 5. So let's start counting vertically. That is going by 5. Skip counting by 5. So this is 5, 10, 15, 20, 25, 30, 35. I'll put 40 there. And skip count by 1 for the x-axis. 1, 2, 3, 4, 5. All right. So for this one, we're going to put, right, the right triangle was created. And we know that slope is rise over run, which is 40 over 5. And 40 over 5, we can simplify that, right? That's just 8. And that verifies what we have in our table, in our graph. And the statement is that we have $8 per shirt, right? $8, it's always our dependent variable over our independent variable. The dependent variable is the total cost. And the cost depends on how many shirts that we order. Right, so that's why it is $8 per shirt. All right, and before we go to the next page, I do want to put your attention to this. This is the formula to calculate slope. So if we're working on our test, right, and you're not sure what the formula is we use this right here. We subtract our y's and we subtract our x's. Now we have these 2's and this 1's. What does that make, or what does that mean? Right, we have, okay, right, we have this x1, y1, or you can read this as x sub 1, y sub 1. This represents the first x and y, or the first points, right? y2 comma x2 comma y2, this is our second point. So what we do in the formula, right, y2 minus y1, I'm going to take this minus this. And x2 minus x1, I'm going to take the first or the second x minus the first x. So just keep that in mind, right? This formula, there's always a minus sign in between the x's and the y's. The 2's always comes before the 1's. The y's are on top and the x's are on the bottom. All right. So we're going to have to apply that understanding for the next page. Let's go to 238 or 239. So to calculate the slope, we have to have 2 points that lie in the line. We have 0, 15, and 1 in 23. And we're already labeling them, where we have x1, y1, and x2, y2. So plugging that into the formula. Now, when you subtract this, I always think it's beneficial to line them up vertically. So I'm going to write the second one, and I'm going to write the first one, so that we know we're going to be subtracting. Right? In this formula, we have y2 minus y1. This is 23 minus 15. When I line it up vertically, 23 minus 15, right? That's going to give us an 8. And the next one, x2 minus x1, 1 minus 0, as you can see here. Right? 1 minus 0 is just 1. And 8 divided by 1 is 8. So $8 per shirt. So we can also write this fully out, $8 per every single t-shirt. All right, so we're going to apply that understanding in the formula just one more time, just to prove that it doesn't matter which points you choose, you'll still get the same answer in the end. So right here, I chose some other points that were on the table, 555 and 339. Using our slope formula, let's rewrite this. And not that we need it, but I'll put that this is x1, y1, and this is x2, y2. Right, if you want to highlight it, you can. But it doesn't matter. So we're always going to set it up with our y's in the numerator. This will be 55 minus 39. So I'm looking right here. We'll simplify that later. And then now 5 minus 3. Right, the reason I line them up vertically is because sometimes students will mix and match. Sometimes they'll put like 55 minus 3 or 5 minus 39. So just be careful with that. In this case, right, if we take away 39 from 55, we're going to get 16. 5 minus 3 is 2. And we still get the same answer in the end, right? You're going to get, if we can divide both these by 2, we get 8 over 1, or just, right, our answer still remains the same. It's still positive 8 for $8 per shirt. All right. The next part we're skipping, where it talks about Selye's calculation. Ignore that. Let's go to page 240. And we're going to compare these various ways of calculating the slope. So we have, well, just reading the question. How is the strategy of using the slope formula given a table of values related to using similar triangles given a graph? So we have a table, we have a graph, right? All in all, you're still going to have the same x and y values, but right, when we think about for a graph, right, we think about rise over run, but it's the change. I'm going to draw a triangle, right? The triangle represents, it just means change, right? It's a change of the vertical distance and change of the horizontal distance. Right, this, although it's a triangle, this is actually I believe it's a Greek letter delta, lowercase delta. It just means the change, right? How far these numbers are away, right? So when we count, right, up, down, left, right, that's how far they're away. So this is for the graph. And then for the formula, right, what we do here, this is the same thing. It's equal to, it's the difference or the change of the y values, or we're doing y2 minus y1. And the second one is the change of the x values. Right? And this should make sense where we're talking about an x and y axis, right? Because right, when we're looking at a change of something that's vertical, the y values, Yeah, the y-axis is the vertical axis. And then the change of something that's horizontal, right? That's the x values. And the x-axis is the horizontal axis. Okay. All right, let's go ahead and move on. This next part, number 6, I'm not going to read the context, but I'm just going to read number 6. It says, examine each example where we're talking about number of games Ron won today and number of credits on Ron's player's card. Follow the arrows, calculate the slope. Does each example correctly calculate the slope? So as you can see, you can find, I'm going to highlight these. You can find the slope using any rows. In this case, this first example, we use the first and the last. This one, we're using the last and the second to last. And then this one, we're using the second and the third. Now, whenever you calculate the slope, you need to begin on the same row and you need to end on the same row. In this case, this does that, right? We begin, we're doing 40 minus 0, and we're doing 440 minus 120. The last one, we begin right on the second, end on the third. Begin on the second, end on the third. And the second one, that is the counter example. We're going to say example 2, I'll just put EX2, incorrectly calculates the slope. So I'm going to put an X here. Now, why is that the case? Right, the reason that it incorrectly calculates the slope is because although we're using the same rows, right? This one starts on the last one and then goes over here. This one starts on the second to last and then goes to the last. We have to begin on the same place. Otherwise, right, this would actually give us a negative or the opposite sign of what we're intended. So in this, we're just going to say we start and end in the, we'll say, wrong place. It's got to be exactly the same position, exactly the same set of ordered pairs, because if we start this right here is an ordered pair. It is 25, 320. But if we switch it, really you're saying that this ordered pair here is 25, comma, you're beginning here, 440. That's not correct, right? We got to start in the same place, right? That's not an ordered pair that we have. All right. Now let's go to the next one for activity 2. Activity 2, we're going to have some you-dos and some problems that I'm going to tackle. So go ahead and highlight this. On number 1, I would like for you to figure out what is B and D. And on the next page, we're going to do just number 2. Well, you'll have to do B and D in that as well. But let's go ahead and calculate the slope for each linear relationship using the formula. We can choose anything, right? Does not matter. I'm going to choose, let me go from here to here. Right? Maybe you want to just choose numbers that you feel like are easy for you to subtract. Right? So which one is the y, which one is the x? If you're not sure, always put dependent over independent. Okay. So for this, is it cost per, this is going to be cost per ticket, right? Because the cost depends on the number of tickets that you purchase. We're going to have, right, so this means that this is the y, this is the x. So we always start with our y's. It's going to be 18 minus 12 and 16 minus 8. If we simplify this, this is 6, this is 8. Right, you can simplify this. You can divide both these by 2. And that equals 3/4 or 3/4. Now, when I say 3/4, think about what that means in terms of money. 3/4 is 75 cents. So what this means for this situation, it's 75 cents per ticket. Okay. So I'll have you do this one right here. And I'll have you do this one. But let's finish up C. For this, I probably don't want to deal with like this big number, so I'm not going to choose the 4th row. Let's choose, don't want to go that way. You know, I'm gonna choose the first and the second, but I'm gonna go like this. I'm gonna go first and then second instead of second and first. So setting this up, right? We already have it labeled as y's. Now always put a minus sign in between the two numbers that you have, right? Because sometimes students will confuse that. I'm gonna put this in red so we know that that's a part of the formula. This is gonna be 13 minus -2. Notice how I'm putting that negative there, not confusing that with the minus sign. And then the next one will be -1 minus 0. To simplify this, a negative times a negative, when they're next to each other like that, this becomes a positive. This is 15. And the next one, -1 minus 0, that's just a -1. A positive divided by a negative is a negative, and 15 divided by 1 is just 15. Okay, so we have our answers here. Again, try to figure that out for the other ones, but let's go to this one to end this example. Which relationships in question 1 are proportional? Now, what they mean by proportional, remember, it has to go through the origin, which means it has to go through 0, 0. This means that the x value has got to be equal to 0. So when you look at the diagram, try to see if you can find where the x value is 0. Here, we already have it, right? The x value right here is 0, right? Is this 0? No. So we can say for C, it is not proportional. I'm just going to put no. Now, for the first one, I don't see where x is 0, but we can find it though. If you look at the pattern for x, I'm going to write it like this, right? This looks like it's multiplying by 2, right? Because 4 times 2 is 8, times 2 is 16, times 2 is 32. So let's go backwards, right? If I divide this by 2, 4 divided by 2 is 2. I'm just kind of writing in here. I'm going to go off to the side here, right? In this case, where we have 1, right? And then in this case, we would have a half, right? 1 divided by, that would be 0.5. In this case, right, we would never get, because if you look right here, this is, looks like it is subtracting, is it multiplying by 6? 3, 6. So what the pattern here, right, this is increasing by 3. This is increasing by 6. This is increasing by 12. All right, so it looks like those are being doubled too. This would not equal 0. So in this case, we're also going to put no. But I'll give you a little bit of a hint for yours. Right, think about for this one, it looks like we're adding 1 as we're going down. Just subtract 1, right, to try to figure out what is this going to be on the right side for vitamins. All right, anyways, let me know, or Mr. Civil know, to check your UDOs. And then from there, we're going to be working on, I believe, Mathia. Okay, let me know if you have any questions.